Okay. All right, so you can just carry on underneath number 1 because that's what we, well, I suppose you've done work in between, hey, or since then. So, okay, maybe we must just make the heading again. Mixed graph interpretation. Yeah, if you left a space, then that's perfect. You can just write there. It's this A5 one that I handed out. What? I counted on this absentee list. There were 7 people absent, but I don't know if people have left since then. But now we've been told to check, hey? For what?
Because there's a great event, so it will be off. No, but I don't have great time. But there was a meeting.
Okay, it's fine. I'll check that later. Don't worry. Okay. This is this A5 page that I handed out to you guys the other day. We did the first example, which was this one. We've done that one already. Now we're doing the second one. All right, the second example. Okay, so I'm just going to quickly write down these equations. They gave us the equations. They said the sketch shows the graphs of the functions. Mr. Smith. Okay. X squared minus 8x plus 7. That's the one equation. And the other one is g of x equal to a half x minus a half. Now, guys, if we're looking at these two equations, I know they've given you the graphs as well, but if they had just given you the equations, can we identify the types of graphs that we're working with here? If it's an x squared, this is a parabola, right? Okay. So that is the parabola. And then the other equation, the half x minus a half, this is a straight line. Good. Then they're giving us some more information in the sentence. They're just saying that E is the turning point of F. You don't have to write all this stuff down. I'm just making sure that we have all the information. So E is the turning point of F. Now, guys, they've given us the equation of that parabola, so we can actually find the coordinates of the turning point, right? As they asked us to. This equation is not written in turning point form, but do we remember that formula for finding the turning point? If it's given in standard form, x is, you can complete the square, but there's a formula as well. X is, it's similar to delta, negative b over 2a. Right, we wrote that down at the beginning. Okay, that will give you the x value. We might have to do it here, so then we'll write it down. If you say x is equal to negative b, so negative 8 basically, over 2 times a, which is 1 in this case, that gives you the x value of the turning point. You then substitute that into the equation and it will give you the y value. Okay. For question A, they are asking for the length, or lengths, because it's 2, the lengths of OA and BC. Okay, that's what they're asking for in the first question. I'm going to put the graphs up now because we obviously have to look at it. Hello? Okay, who was that with? Oh, I did actually see that as I was walking past. Okay. OA and BC. Now, guys, we need to look at the graph. Sorry, it's not very clear on here, but you should have this page in front of you. O is the origin, right? So if they're mentioning O at all, that's the point that they're talking about. They're asking for the length of OA. Now we need to recognize that OA is a line, a part of the y-axis, going from the origin to point A. Now, what kind of point is point A? What intercept? Y-intercept of the parabola. Do we notice that? Right? A is the y-intercept of the parabola. So if we find that point, that's going to give us the y value here. So say that's a 6. I'm just making that up. All right, we'll check now what it is. Say that's 6 and that is the origin. What is the length of that line then? From 0 to 6 would be 6 units. Okay, so that's what we need to do. So for the first bit, OA, let's write that A is the y-intercept of F, which is the parabola. So we need to find that value. Now, guys, remember that to find the y-intercept of any graph, you can always make x equal to 0. All right? The y-intercept of any graph, make x equal to 0. But if they've given you the equation of the parabola in standard form, do we remember that this value, the c value, is actually your y-intercept? Okay, that's something that you can just memorize. I think we did it in the note. Not sure if this, this note is only from hyperbolas. When we did parabolas right at the beginning, remember we wrote down the 3 forms. Okay, if it's given in standard form, then that is your y-intercept. Because guys, if x is 0, what's that first term going to be equal to? 0, right? 0 squared is just 0. Minus 8 times 0, what's that thing? Also 0, plus 7. Okay, so if you make x equal to 0, which you can do for any graph to get the y-intercept, you will get 7 anyway. Okay, so for the y-intercept of f, I'm just going to write here, make x equal to 0, or it's the c value of the equation. So therefore, A is the point 0, 7. And O is the point 0, 0. Now, if we're going back to the graphs, if that is 0 and that is 7, what is the length of that line, that section of the y-axis? 7 units. All right. So therefore, OA is equal to 7 units. Or if you couldn't tell from the graph, maybe you had complicated values, you could actually work it out using a little formula. Because it's a y length, right? I hope that makes sense. It's a length that you would have to read off along the y-axis, okay? You could take the y value of A minus the y value of O. The y value of the top point minus the y value of the bottom point. It will come up now when we're doing more questions, which in this case will be 7 minus 0, which will also give you 7 units. Okay, that could be useful if you maybe can't just see it easily from the graph. In this case, it was easy to see. It might not always be. Okay, so always the top y value minus the bottom one. So if A was underneath, if A was down here somewhere, you would take 0 minus that value. Okay, and it will then give you the length of that line. Okay, so that is for OA. For BC, now guys, I just want to give you a hint here in terms of getting marks. If you don't know how to find the length, but you can at least see, okay, they're asking for the length of OA. Do I have A? No, let's calculate A. All right, even if you're just finding the coordinates of A, you will get a mark, 2 marks possibly, depending on how complicated it was. Okay, so if they are asking you for the length of a line segment, make sure that you have the points that form that line segment at least. Maybe you won't be able to then get the length from that, but you can get marks for getting that or those coordinates. Okay, now we need to find the length of BC. Now, guys, B is over here and C is over there. So we need to find that length now of that line segment. Do we notice that this is a section of the x-axis? Now, what are points B and C? What kind of points are those? X-intercepts of the parabola. Can I calculate that? How do I find the x-intercepts of a parabola? Make y equal to 0. Okay, so B and C are the x-intercepts of F. Yeah.
Let's figure out the roots and then just combine
That is what I'm going to do now, yeah. X-intercepts, roots, same thing, yeah. So they gave us the equation, right? X squared minus 8x plus 7. So we're going to do that. X squared minus 8x plus 7 equal to 0. So we're making y equal to 0. And now we're going to solve for x in this equation, right? Which is a quadratic equation, guys. That one isn't too bad to factorize. Okay, you can obviously always use the quadratic formula if you want. But if it's an easy one to factorize, that will save you time. Okay, let's look for factors of 7. When I add them together, I must get negative 8. 7 and 1, but it's going to have to be negative 7 and negative 1. Hey, like that. If that scares you, if you feel like you're going to sit there for 10 minutes trying to factorize it, rather just use the quadratic formula. There's nothing wrong with that. Just remember, if you are using the quadratic formula, you have to show what you're subbing in. So that substitution line where you're putting in your B and your AC, all those values, you would get a mark for that. So guys, if these are my two brackets, then what are my two X values? 7, or please guys, you always have to write or, okay? I know that they are both X-intercepts, but this is just a notation thing. X can't be equal to two values at the same time, which is why we write or. Okay, so therefore, B is the point. If we're looking at the graph, we have 7 and 1. So B, is this one 7 or 1? 1, right? It's the one with the smaller x value, and that is going to be the one with 7. So B is the 0.10, and C is the 0.70. You don't really need to write that down in order to get the length, but in case they possibly asked you for the coordinates, you would have to write that down. So now, guys, if we're finding the length between 1 and 7, what's that? What do we think? If this is 1 and that's 7, what's that length? 6 units, hey? So now you're going to take the x value that's bigger, the x value of C, and you're going to minus the x value of B. Right, or like we said, we can just check. If you're going from 1 to 7, obviously that's 6 units. But if you wanted to do a calculation, you could do it like that. So you can say that BC is 6 units just off of the graph. That's perfectly fine. Or you can use a formula where you say the x value of C minus the x value of B, which is 7 minus 1, which is 6 units. All right. Does this seem familiar, guys? Do you remember doing similar stuff last year? I suppose you also could do similar questions when you did trig graphs, where they would maybe ask what is f of 180 minus g of 180, a similar kind of thing. All right, so that was A. Now B is a bit more complicated. They are asking for the length of DE, right, which I'll show you now on the graph what that actually is, the length of DE. Now, I think that must have moved, that little square. I think it was supposed to be over there, sorry. It must have moved and I didn't notice that it moved. They're supposed to show you there that that is a right angle, okay? And what that is basically telling us, guys, is that points D and E are directly in line with each other. E is directly below, we're not sure how far below, but E is right below D, okay? Now, if they set up like this, guys, are they going to have the same X value or the same Y value? What do we think? They're going to have the same X value, right? Can we see that? D on the X axis has exactly the same X value as E. Now, how can we find the X value of E? Because D isn't actually a point on either of our graphs, right, Haley? It will be, yes, but why is that? But that also comes from E being, you are correct. I'm just, hey, Nicholas. Yes, E is the turning point of the graph, right? Now, guys, it is true that the turning point, and I'm not sure if we actually wrote this down, but maybe it makes sense to you. Like Haley is saying, a parabola is symmetrical, or symmetrical, about the axis of symmetry. In a sense, what they've drawn here are 2 points on the axis of symmetry, right? Because the axis of symmetry, remember, is an X line. So it's a vertical line that goes through the turning point, all right? And then it goes all the way up. So if we have B and C are 1 and 7, all right, then D and E, those 2 points will lie directly halfway between your two X-intercepts, right? So if this is 1 and that is 7, remember that's 6 units. So what must this distance then be? Half of 6 is 3, and then that will also be 3 units, right? Does that make sense? Okay, so let's write that down, guys, so that we have that somewhere at least. D and E lie on the axis of symmetry of F. And then we can just put in brackets, E is the turning point of F. All right, so now I'm going to say the X value of D is going to be equal to the X value of E. I hope that that's fine with you guys. They have the same X value, right? That's all that I'm saying there. Now, guys, if you wanted to work it out, if you're struggling to get that halfway point, all right, maybe it's negative values, maybe it's big numbers, maybe it's a bit difficult to see, you can literally do like a midpoint calculation, right? So you can take the two X-intercepts. The two X-intercepts were 1 and 7. You can add those two together and then halve it, right? Does that look familiar? Do you guys remember finding the midpoint of a line? You would do that with the X coordinates and then with the Y coordinates. Okay, so I'm basically finding the value that's halfway between the two X-intercepts. Halfway. And guys, you can always use this method if you are finding the turning point of a parabola. All right, we have that formula. We have the minus b over 2a formula. We could have used that because we have the equation, but we might not have the equation. They might just tell us these are the two X-intercepts, find the turning point or something like that. Okay, then you can always use this to find the X value of the turning point by adding the two X-intercepts together and then dividing that by 2. So you're finding the value that's halfway between the two X-intercepts. So 1 plus 7 is 8, divided by 2 is 4. Right, so that's the X value of those 2 points. Does that help us though? Does that help us to find the length of DE, knowing that they both have an X value of 4? Well, it will help us eventually, but can we find the length just knowing that information? We actually need to know the Y values, right? Because as we can see, this is a vertical distance, a vertical length. So we need to know what that Y value is and what that Y value is. Now, guys, from the graph, we can see what is the Y value of D. It's on the X-axis. It's 0, right? Does that make sense? How am I going to find the Y value of E? Turning point, so I'm going to sub X equals 4 into the equation of the parabola. Okay, so therefore D is the 0.40. Just writing that so long. To find E, we have to take the equation. So that was Y equals, just going to show you at the top, this was the equation of the parabola. So I'm going to put 4 now for X. All right, I'm going to substitute X equals 4 here because that's the X value of the turning point. We're needing the Y value. So I'm going to do 4 squared minus 8 times 4 plus 7. I could do that in my head, but I'm lazy now. So let's just double check. 16 minus plus 7. Okay, that's negative 9. Right, so that is the y value of E. So E is the point for -9. So what is the length of DE then? If it's going from 0 to -9, how many units is that? 9 units. Okay, from 0 to -9. So therefore, DE is 9 units. Or like we've done with the previous ones, you could take the y value of D because it's the one that's highest, minus the y value of E, in which case you will have 0 minus -9, right? Which does end up giving you 9 because a negative times a negative is a plus. Okay, are we fine with that one, guys? So with these length questions, are you noticing that we can actually answer the questions if we're finding the coordinates of the points every time? Okay, so that would always be your starting point. If they're asking for the length of a line, then you need to find the coordinates that are at the end points of those lines. Okay, can I turn the page? Are you all done there? Right, the last question is obviously the most complicated one. Now they're asking for the lengths of OH and HI. Or lengths, sorry. Now I'm just going to write here at the top, O again is the origin. Okay. So we have that at least. Now, if we're looking at the picture, OH is there. Now, guys, is H even a point on one of my graphs? No. Okay, so we're not sure what's happening there. Do we agree that I need the X value of H if I want to find this length? Because it's going from 0 to whatever that X value is. Okay, so somehow I need to find the X value of H. What are they showing us here? They actually should have put this in as well. Sorry, just add that there. They should have shown you there that that's also a right angle over there, showing that I lies directly above H. Now, guys, is I a point on one of my graphs? It's in fact a point on both of my graphs. Do we notice that? Yes. It's just how it's printed. Yeah, sorry, the quality isn't great. I is the point of intersection of the two graphs. Right? Does that make sense? So I is the point of intersection. Now, guys, what is going to be the same of H and I? They are going to have the same X value. Good. So if I can find I, then whatever that X value is will be the X value of H as well. All right. Now, how do I find the point of intersection of two graphs? You solve them simultaneously, right? You have the equation of your parabola and the equation of your straight line. You're going to solve them at the same time. So to do that, we make the two equations equal to each other. Okay, let me just quickly write here. I is the point of intersection of F and G. Those are the two graphs that we're working with. So we're going to solve the two equations simultaneously. So I'm going to write the equation of F. It's x squared minus 8x plus 7. I'm going to make it equal to the equation of G, which is a half x minus a half. Guys, what type of equation is this? Yes, but then further than that, it's a quadratic. What do I need to do when I have a quadratic equation? everything on the one side equal to 0. Guys, before we do that though, let's make it a bit easier for ourselves. I don't like working with fractions in an equation. I don't know how you guys feel. All right, so what you can do to get rid of those denominators of 2 is you can just multiply every single term by 2. Okay, do you guys remember solving an equation with fractions? You multiply each term by the LCD. So I'm going to multiply that by 2, that by 2, that by 2, and that by 2, and the last term by 2. Right, you multiply each term by the LCD, which you are allowed to do when it's an equation. Because now those 2's are going to cancel out and those 2's are going to cancel out, right? So you won't be left with those fractions. So I'm going to have 2x squared minus 16x plus 14 is equal to 1x minus 1. Okay, now like terms, when I move this x over, it's going to become negative x. So I have my 2x squared minus 16x minus x is going to be negative 17x. And then I have my plus 14, but this minus 1, when I move it, is going to become a plus 1, right? So that's plus 15. Now, this is not such a nice one to factorize. Okay, so can we use a quadratic formula? I'm sure you can factorize it if you want to. If you feel comfortable with that, please go ahead. But let's also just practice using that formula quickly. Yes.
Wouldn't that be easier with just putting in one and doing all?
If you want to do it like that, perfect. Yes. Yeah, go ahead. No problem. All right. Negative b, so negative 17, right? And guys, it's important, remember, whenever you're using the quadratic formula, you write this step down. Plus or minus the square root. Sorry? No. If it helps you, though, to write it down properly, then, I mean, it's a good idea. But no, you won't get a mark for it. Okay, then the next term is minus 4ac. So a is 2 and c is 15. That is all over 2a. So 2 times 2. If that is not written down, you lose a mark. Okay, so what are those values? Let me just check quickly. Okay, the 1 is going to be 15 over 2. And the other one is going to be 1. It should be fine if you make it positive 17 straight away, yeah. Okay, so x is 15 over 2 or x equals 1, just 1 like that. Now, what is 15 over 2, guys? What value is that actually? Now what? Oh, sorry. Yes. Okay, so this is 7,5. Right, so we're getting 2x values. What does that mean? What were we trying to find here? The point of intersection. But let's just look at our graphs. Oh, sorry. We do actually have 2 points of intersection, right? That's why we're getting 2x values. Do we see that the 1 point of intersection was point B, and we already saw that the x value of B is 1. Okay, so we are getting x equals 1 here, which is correct. But this is the x value of B. So we're not going to work with that further. Okay, we're not actually interested in B at this point, meaning that 15 over 2 or 7,5, however you want to write it, this is the x value of I. Right, so you do have to look at your graph to identify which point it is. Right, 1 is obviously smaller than 7.5. So 1 is that one, and that one is 7.5. Okay, so guys, if I know that I has an x value of 7,5, remember we said that h has that same x value, right? So therefore, h is the point. You can write 15 over 2 if you want, or 7,5, it doesn't matter. H is that point, 15 over 2, 0. So what is OH then? If it's going from 0 to this point, it is 7,5 units, right? From 0 to 7.5. So OH is 7,5 units. Or if you want, you can write 15/2. There's no preference there. It's fine to leave it as a fraction. Okay, so we found OH. We still need to find HI. Now we have the X value of I. If we're looking at HI, is the X value enough for me to get HI? I now need also the Y value. Now guys, as we can see here, I lies on both graphs. So when you're finding the Y value of I, you can decide to substitute that X value, 7.5, into the straight line equation. That'll give you the answer. Or you can substitute it into the parabola. Which one is quickest? The straight line, hey? If you sub it into the straight line equation, that's just the quickest calculation. But you're using your calculator anyway, so it doesn't matter. So to find point I, we know that X is 7,5, therefore Y. And now I'm subbing it into the straight line equation, but like I said, if you wanted to, you could sub it into the parabola equation. So that is going to give you 13/4. Or you can write that as 3,25. Again, it's up to you, whatever you feel more comfortable with. So I is the point 7,5 and 3,25. Or 15/2 and 13/4. So guys, if those are now the 2 points, they have the same X value. What is the difference or the distance between their Y values? 3,25. So that is the length of HI. All right. Therefore, HI is equal to 3,25 units. Again, starting point is finding the coordinates of the points that make up that line segment. All right. If you are only doing that and you're not quite sure of how to then get the lengths, you will at least get credit for calculating the coordinates. Okay, that's fine, guys. All right. Are we all done with that exercise 13? Do you want to mark those questions quickly? I can also post them on Classroom, but just for those of you that do want to see them quickly, I do have them here. Yes? Okay, there we go. So this is exercise 13. You had to do 7 and then 8.1 to 8.9. If you're still busy with that, you can just mark whatever you've done and then carry on. And now, guys, you'll be able to do the rest of number 8 as well. Okay, we've done 8 to 8.9. So if you feel like you need more practice, especially in these length type questions, you can now do the rest of number 8. Okay, for number 7.1, they gave you the equation. They said that this was f of x. They gave you the turning point, which was 2, 8. And they gave you another point on the graph. They asked you to find the equation of f. Now, guys, like we did before, if they're giving you the turning point, you're going to use turning point formula. Okay, which is what I did here. So even though they've given you the form, or they've given you the equation in that form, you have to use turning point formula to get to that form. Okay, so that was your starting point. Recognizing that you have to use this formula, subbing in the turning point, and then subbing in the other point, which was -4, -10. That then allows you to find your A value, which I got -0.5. And then, guys, I think if they've asked you, if they're saying that f of x is in this form, you then have to actually write your answer in that form. Okay. Oh, they actually asked for the values of A, B, and C. Sorry. So you did have to write it in that form in order to identify what B and C were. So you already had A here, but to get B and C, you had to actually multiply all of that stuff out. Okay, I wrote the value of A down here again. You didn't have to write it a second time. It was up there already. I just like having everything summarized at the bottom, but it's fine. You'll get the mark up there. Any questions on that one? All right, 7.2 was finding the values of D, E, and J. So that was of the hyperbola. So I just put in my two asymptotes. It was x equals -3. Remember, it's then x plus 3 in the equation. And the y one was -2, so it's -2 in the equation. Then I subbed in the other point, which was also -4, -10. That allowed me to solve for D. So then I just wrote my formula so that I could then just read off all the values. Now, guys, if you, again, wrote D equals 8 up there already, you would get the mark there. You don't have to write it a second time. I just did. And this equation, I just want to go up quickly. They gave it to us in this form. Did you guys notice that this is different from what we worked with? We worked with an x minus whatever, all right? But guys, if they're giving it to you in this form, you have to use this form. So that's why I think it's easiest to actually write the equation of the graph. And then if you know that it's x plus e and x plus 8, then e has to be +8. Right, so look at the form that they've given you, and then your answer has to follow from there. And then J was -2. Okay, and then there is 7.3. I have two calculations here at the bottom for finding K. Just see it's faded there. So you can just look at that. Now, guys, when you are finding the equation of an exponential graph, I always sub in the y-intercept first, right? They're giving you multiple points. The y-intercept is usually one of those points. The q value was easy to see because that was the asymptote, all right? So your q value, -2, that one you could see just by looking at the graph. Now you still have to find v and k, all right? So we need to still find two variables, and we still have 2 points that we can work with. But my tip to you is to substitute the y-intercept first, because the y-intercept always has an x value of 0. And when you make x equal to 0, what is anything to the power of 0? 1. All right, so if you just have a something, whatever, it's k to the x in this case, and you make x equal to 0, it's actually going to cancel out that whole variable. All right, which is quite nice, because then you can just solve for v. So first sub in the y-intercept always, all right, because that takes care of that. Then I got that v is 1. So now if v is 1, do you agree with this? That y is just 1 times k to the x minus 2. You don't have to write that 1. Now you can substitute the other point, which was -1, 0. And then you can just look at my two ways of solving here. If you look at it in this way, it's an exponential equation, right? K to the -1 equal to 2. Remember, when you're solving an exponential equation and you're solving for the base now, you have to get the exponents the same, which is a bit more difficult. We're used to having like an x in the exponent, so then you must get the bases the same. All right, this is the opposite. Your variable is in the base, so now you must get the exponents to be the same. So 2 is 1/2 to the -1. Not sure if you would have thought to do that. So then k has to be 1/2. Or you can just convert it, right? K to the -1 is the same as 1 over k. And then in this case, it's just multiplying by k and then dividing by 2. Okay, so this is an easier way of solving for k, but you do have to make that switch. It's actually coming from this line to that line. So where you have k to the -1 equals 2, you change k to the -1 to 1 over k. And then you're going to have to multiply the k out. So you get that, and then to get k on its own, you have to divide by 2. Now, in this question, they didn't ask for the equations of the graphs, but it's quite useful. There was nothing that came after this, but usually they might ask for the equations, then they ask other questions afterwards. So it is useful if you actually have the equations written down so that you can use them further down. But yeah, they didn't ask for it in this case. So don't worry if you didn't write that. They just wanted the actual values of all those letters. Okay, I'll post this on Classroom, guys. So if you are needing to write stuff down, then you can do that later. Okay, then for question 8, for 8.1, they asked for the axis of symmetry. So what you could have done was you could have actually just found the equation of the graph. and then use your axis of symmetry formula, that would have worked. It would have just been very long. So what I did is what we just did in that previous example, right? Where the axis of symmetry is at the x value of the turning point. So therefore halfway between the two x-intercepts. All right, because I think we actually had the two x-intercepts, those were given. They told us that the one is -2, the other one is 4. So you could use that as like a shortcut. So if you did it the other way, guys, if you found the equation and then the turning point or the axis of symmetry, that's fine. But just write this down, all right, as an alternative solution. And you would probably only get 2 marks for this question. So if you went through the whole thing of finding the whole equation, then you would still only get 2 marks for that. All right, for 8.2, they were asking where is the parabola increasing? So that's literally where it's going up, right? So the turning point was at 1, that is here, and the parabola looked like, this pen works. It looks like this. And this is now the turning point, right? So I'll answer from there. So that's x equals 1. So here the graph is decreasing, right? Because it's going down. The y values are getting smaller. But on that side of the turning point, that side of the axis of symmetry is increasing. So that's why we say x greater than 1. Okay, at the turning point, it's not actually increasing or decreasing. It's in between the two. Okay, so that's why I didn't include 1. You just say x greater than 1. If it was a graph like this, then for this section, it's increasing, and for that section, it's decreasing. Yes. It depends on how the graph looked. For 8.3, they asked for the axes of symmetry of the hyperbola. You didn't actually need the whole equation of that graph. You just needed the denominator and the q value. Right, remember we copied down, it was actually a lesson that I recorded for you guys. To get the axes of symmetry, I had it here somewhere. Oh, it's in this note. Let me just show you quickly. Those are the 2 formulas for the axes of symmetry, right? Y equals the denominator and your q value. And then the other one, y equals negative the denominator and your q value. And remember the denominator and the q value you get from your 2 asymptotes. Okay, so that's what I did in that one. Okay, we did calculate further down in 8.5, but you didn't need it for this. All right, so the denominator was x plus 2, because that asymptote was -2, and the other asymptote was -1. So that's the one equation, and then that is the other equation, then you just need to simplify them. Okay, for 8.4, where was the one graph smaller than or equal to the other graph? So F was the parabola. Oh, sorry, and G was the hyperbola. Did you have the points of intersection? 1 and 4, -1 and 4. Was that given on the graph? Right, so guys, it was just in between those 2 points of intersection where the one was smaller than the other one. I'll just show you here. What page was this on? 106, thank you. So it is F smaller than or equal to G. So F is the parabola and G is the hyperbola. No, G is, yes, G is the hyperbola. So how did I know that this was a 4? F, oh, it's there, sorry, wow. No, it's not. Yes. So I actually had to calculate this point. Oh no, okay, my answer is wrong. Okay, guys, so how would you find this point? How would you calculate this one? The whole simultaneous equation thing, right? I think I might have calculated it further down. Let me just check. Yes. You would have a, let me just check, because I did find it somewhere. I found the point of intersection of G and H. Yeah, which is different. I didn't actually calculate it. Okay, guys, I'll just redo that, but let's just look at this section on the graph at least, so that we understand that section, how to read it off. So that is the one point of intersection which we do have, and that is the other point of intersection which we don't have, which we'll have to calculate, because they are asking, guys, they were asking for F and H, not F and G, so it is this. F and H. F and H. They didn't ask about F and G. No, sorry. I'm talking about G. I had a brain moment there, a bad brain moment. Sorry. Okay, let's get back to this. We don't have to worry about cubics at all. They're asking where is F, the parabola, smaller than H, the straight line. Okay, so my answer is actually correct. Sorry, crisis averted. Sorry about that little panic. No, you don't have to. So they're asking for F and H. So guys, does it make sense that, because they're asking where is F smaller than H? For this whole section, do we see that H is that green line there, and the parabola is very clearly underneath the green line? Right? Do we see that in that section there? So that's why it's between -1 and 4. And we are including those two values because they asked for where they equal as well. I'm just going to mark until 8.5 because you guys look like you are the most bored than you've ever been in your entire life. And you can carry on. 8.5, they asked for the equations. So for F, I used, now you might have done this already in 8.1, in which case you would just rewrite the equation, that's fine. For F, I used the X-intercept form because they gave us the two X-intercepts. Right, they were at -2 and 4, so x plus 2, x minus 4. And then to get A, I subbed in the other point that I had, and A was just 1. Now, guys, again, because they gave us standard form, they said F is y equals ax squared plus bx plus c, you have to write your answer in that form as well. Okay, so if you get it like this, this is actually an okay equation, but you have to give it in the form that it was asked in. That makes sense. For G, you had your asymptote values already, and then then I just subbed in the other point, and I got that equation. Okay, guys, I'm not going to talk through the rest. I'm just going to post it on Classroom. If you have questions on the rest, you can ask me. But use the 10 minutes that you have left now to carry on working on this number 8. And then tomorrow, you can just do whatever revision you would prefer. No, not in this box. I think. Oh, you were actually 8.5. Sorry, I'll add that quickly. Yeah, I didn't do that. I just did F and G. Normal time?